freight train rumbles through a snowy mountain pass. 6 snowmen, Frosty, Chili, Blizzard, Icicle, Snowball, and Flurry, are stacked haphazardly on a flat car, their carrot noses wobbling with every jolt of the train. The wind howls, but they're having the time of their frosty lives.
Hello everyone. What you just saw was my snowman car prototype that can run on track power. And the issue with running an accessory like that on track power with a Raspberry Pi Pico, where you see underside here is my Pico and then my board with the audio and stuff, is you need to be able to handle track interruptions of power because the processor will reset. And so the way I handle that in this particular prototype is I have a supercapacitor here. I'll explain what those are in a little bit. And then I have this circuit here which has a little pot that will hold the 3-volt enable down low until it gets up to about 3.5 volts. What that does is it holds the processor in reset until it actually has enough power to run properly. The problem with that is these servos do not like to be powered up slowly. They end up getting destroyed. I think this comparator circuit that's in here just doesn't like that. And also the NeoPixel board that I have here that controls the lights also kind of gets stuck. So the issue is you can't bring power up slowly on a microprocessor system which has servos and other things. You need to turn the power on when it's good. And so they have power management chips that basically will put a signal on when the power is good. And you can get them for different voltage values. So what I'm going to explore in this video is how to use supercapacitors and what kind of circuit that we would need to actually make it work. Before we talk about supercapacitor, let's talk about your standard electrolytic capacitor. Basically, it's 2 plates that are wound in a spiral and put in a can. They don't have a lot of microfarads to them or farads to them, and basically it's because of surface area. They just have relatively low surface area. That's what creates the capacitance. A supercap, on the other hand, doesn't use plates that are wound. It uses a porous carbon electrode. And what's cool about that is, because it's porous, just think of it like as a sponge. There's so much surface area on that carbon electrode that you can get capacitances up to a farad, which is like 6 times, or 10 to the 6, of what electrolytics could do in the same package size. The one thing that's interesting about these is that they generally only can go up to about 2.7 volts, and it's very sensitive that when you put 2 of them in series that they all have to charge at the same time. So what companies do is they match them with their parameters so that they can put 2 in series and you can use them at 5 volts, which is what I'm doing. Okay. So let's look at my circuit here. So currently the power supply that I have built into all my products that are run on track power, or even those that are run on accessory power, uses a NPM 3620 buck converter. Now, the neat thing about this thing is all you need is external resistors, and these caps here are just like noise filters. They're not really needed for this chip. So what's cool about it is you don't have to put an inductor in there, and inductors take a lot of space. So I love this chip. It's great. It has internal current limiting, so it only charges at a certain current, which is great for a supercap, because when you put a supercap in a circuit, it's almost like a direct short circuit. It's just like, boom, it's like got all this capacitance, it just short circuits basically. So what happens when you hook this into the output of the NPM 3620 is it maintains a current level that's acceptable to the cap. So I have this cap in the circuit. I don't have any way to turn off the output to the follow-on electronics downline. I was using, like I mentioned before, the reset circuit with a voltage divider to the 3-volt enable, which is kind of a bad way of doing things. What's cool about this chip, if you notice, it has a power good output. And what that does is it basically grounds everything until it's good, and then it just lets go, and it then the circuits down below can handle it. Part of my frustration in actually trying to figure out the proper circuit for this was there just seemed to be no information online that I could find that showed the exact circuit that I need. And so what did I do? I went into the Adafruit forum, which Adafruit is a great company. They have tons of good electronics that's easy to use. It's how I got started with my company. And they have tons of tutorials and great software, etc. And so I asked in their forum on circuit design. I told them my problem, and then basically told them what I was thinking of doing with Zener, which basically Zener only conducts when it breaks down at a certain voltage, which would make this MOSFET conduct, in theory. I never tried it because Adafruit Mike, basically Adafruit support Mike told me, hey, use this circuit, use something like a power management chip. I didn't actually know that the NPM 3620 had a power good line at this point. I just didn't know. I didn't look at the data sheet. Here he's showing it switching power. I wanted to switch ground, and then he explained to me why that wasn't a good idea. When you switch ground, you can have some weird things happen. It's best to keep a ground plane and switch the actual voltage instead. So here I have a circuit where I was going to do the ground switching, and then that just wasn't the right way to go. So what we ended up coming up with was this circuit where we have a transistor basically pulling the base to the ground to turn this off, and we're switching the 5-volt power instead. Now, how a MOSFET works is that there has to be a difference between the gate and the source, I believe it is. And so in this case, this I don't actually have drawn correctly. I have this backwards because basically it has to. I have to use a P-type MOSFET, which just basically is the reverse. So you have to have a negative voltage over the gate to source. So I'll show that circuit next. So my previous circuit was backwards with a P MOSFET, and the reason for that is the gate to source voltage needs to be negative on a P MOSFET. So when this is a high voltage and we ground it through this MOSFET, basically that would be a negative voltage and it would conduct. So basically how the circuit works is P good is grounded when there's no good power, which basically keeps this from conducting. And so this is pulled high relative to, it's pulled up to V out. But V out and V out are the same. So this doesn't conduct at all because they're the same voltage and you need a difference of voltage. So then when P good lets go, basically it allows this resistor to pull this high. This starts conducting, which basically pulls this gate to ground. And so ground is negative relative to V out. And so then this conducts and hooks up to VCC. Okay, before committing to this design, I need to prototype the circuit. So what I'm going to do is take one of my power injector boards that don't come shipped with NPM 3620, and I'm just showing you how I laboriously apply solder paste with a toothpick, which is really crappy. Here's the NPM 3620. It's a QFN part. You can see all the pads are on the bottom. That's what makes it a little difficult. So what I'm doing basically is surface mounting this part with a hot air gun. And so you heat up the board, you kind of circle around till the board gets warm, and then you kind of concentrate it, and it ends up melting like this. And now I'm kind of moving it with a toothpick to get it located. Next step is to add a little bit of flux, and then you use an iron to kind of get all the pads to go together. Basically, capillary action is your friend in this case. It just kind of just works. Next, you clean up the board a little bit, and then the next step that I'm going to do is I'm going to actually, I use toothpicks and Q-tips and sometimes brushes. Next step is actually to go ahead and super glue a little wire, a 30 gauge wire on, and then painlessly, or painfully, solder to the power good pin. And I got good at this after a while. I've done 3 of these boards. You can see now it's not grounding anywhere else, and it's ready to do the next step. Now that I got the power good pin soldered, I run it through a little hole on the back side of the board. That's an orange wire, and it goes on the right like that. You can see the super cap, about 1.5 farads on the left, and then the red wires on the right. That's for tracked power. Here's a close-up. We have the purple wire, that's the output. The orange wire is the power good. The yellow wire is the 5 volts from the QFN part, the MPM 3620. And then the perf board there is an insulated perf board. You can see the 2 MOSFETs and 2 resistors mounted on it. And this circuit's ready to go and be tested. So the candidate I chose to actually put this board in was my Christmas on Wheels car. You can see here the previous version with the pod on the left and the super cap. This works okay on the Christmas on Wheels, but it's not ideal. So here's my board installed. I basically removed the cap and put the board in with a super cap, and now it works. So now I'm ready to test. So I turn the power on. You notice the amps go up to about 2.0, and then they drop down. The super cap is charged. And then you'll see the lights go on in the assembly to show you that's initiated, and then you'll hear the initialization voice.
Your animator is now available on your home network. To access, type animator-christmas-wheels. Local in your browser. Animations are now active.
Then the animation plays. At this time I press the power button and turn it off, and you can see it runs for a little bit. Thank you for watching my video. If you like more of these, please like and subscribe and tell others about the channel.